So we are now done with the review of the member analysis and design for steel beams and steel columns, the checking of the local backlink as well as the computation of their corresponding capacity, as well as the design or analysis of members subjected to combined compression and bending. Let's now move on to the analysis and design of connections. But before we proceed with the sample problem, let us just have a quick recap of the different code provisions related to the analysis and design of connections, starting with the provisions related to bolts and threaded parts, which can be found from AASC section J3. So everything that you need to know about bolts can be found on this section. The minimum bolt pretension, expressed in kips, as well as expressed in kilonewton. So parehas lang yan halos, yung isa naka-kips lang, yung isa naka-kilonewton lang. That's why makikita niyo yung table niya, nakalagay table J3.1M. Ibig sabihin ng M metric or SI units siya, naka-SI units siya. Okay. Then you can also see yung table J3.2 kung saan natin makikita yung mga nominal stress of fasteners and threaded parts. Makikita nyo dito yung mga nominal tensile stress for different bolts as well as yung nominal shear stress capacity nila. So magkaiba yung tensile stress tsaka yung shear stress capacity ng bolt. Kasi kung ito yung bolt, kung yung load na in-apply mo sa bolt ay pag ganito, ang strength na magagana sa kanya ay yung tensile kasi hinahatak mo siya eh. Pero kung yung load na in-apply mo sa member mo or sa bolt mo na yan ay pag ganito, ang mag-a-apply dyan or yung gagana is yung shear strength niya. Okay? So depende yan sa paano mo ina-apply ng load yung bolt. Okay? So later on, gagamitin natin yan mga table na yan. Okay? After that, let's now move on sa computation ng tensile strength of fasteners. So kung ito yung fasteners natin, for it to have a tensile failure, you have to apply a load parallel to the axis of the bolt, similar to this. Nakikita natin sa screen. Okay? So yung nominal strength of one fastener in tension, which is in this case, ganyan, is equal to this formula. Rn is equal to Fu ng bolt, yung superscript na B, ibig sabihin lang nun, Fu yun ng bolt. So, medyo baka kasi ma-confuse kayo kasi may Fu rin ng plate, may Fu rin ng bolt. So, para hindi kayo ma-confuse, pag Fu ng bolt, yung gusto nating pertain, lagyan lang natin siya ng subscript. Okay, so this is the Fu ng bolt times An, yung net area ng bolt, which is also equal to 0.75 ng area, yung area ng mismong bolt. Yung net area kasi ng bolt, kung mapapansin nyo kasi yung bolt, meron siyang threads. So kung titignan mo yung bolt sa zoomed area, parang ganito yung itsura niya. Nung some portion ng bolt natin, parang ganyan. So when we say net area, yun yung area na to, yung dun sa may part ng thread. Sabi natin yung area B, eto yan, yung buo, yung walang threads. Okay, so theoretically, yung AN, yung net area is just 0.75, no? Mismong area ng bolt. Okay? Or, kung pagsasamahin natin yung 0.75 FUB, that is also called FNT. Okay? So, later on, define natin isa-isa yan. So, yung FUB, that is the tensile strength of the bolt material. Pag A325 na bolt yung gamit mo, ang value ng FUB ay 120 KSI. Pag A490 na bolt, 150 KSI yung FUB niya. Yung AN, that is the net area through the threaded portion of the bolt, known as the tensile stress area, which can be computed using this formula, 0.785 quantity diameter ng bolt minus 0.9743 over n, quantity squared, wherein yung n is the number of threads per inch. Okay, so bilangin mo lang ilang threads yung meron per inch dito, yun yung n natin. That's how you compute an. You can use this formula for the computation of n. Pero seldom use naman yan. AB is the gross cross-sectional area of one bolt. Doon sa unthreaded part, doon sa walang threads. Kung may area ng bolt doon sa part na walang thread, that is the AB that we're talking about here. Yung 75% ng gross cross-sectional area of one bolt, approximately that is the area at the root of the threads dito sa mga mismong thread. O yung tinatawag natin na net area rin. Yung FNT, as I mentioned a while ago, that is 0.75 FUB, which is the nominal tensile stress of the bolt, which can be found sa ASC table J3.2. So makikita nyo dito, kung babalikan natin yung table na pinakita ko kanina, yung FNT na yan can be found dito sa table na to. Ito yan. So yung mga FNT na to, yan ang lagay dito, FNT. Yan yung mga values that we can use for the nominal tensile stress or capacity of different bolts. Kung A307 volt yung gamit natin, nominal tensile stress is 45 KSI or 310 megapascal. Yung naka-quantity, yun yung corresponding value niya in megapascal. Kung naka A325 ka naman, na not excluded yung threads from the shear plane, or kahit naman yung excluded, parehas lang yung nominal tensile stress, 90 KSI or 620 megapascal. Pag A490, 113 naman daw, and so on and so on. Okay. So, doon mo kukuha yung value ng FNT. Yung mismong code provision related to the computation of the tensile strength of fasteners can be found dito sa AISC-J3.6. So, yung formula na nandun sa code na yun is similar to this final formula na makikita. So, yung FNT na yan, ito lang din yung FN. Then AB, the cross-sectional area of the threaded part of the bolt. Okay. So, yung fee na ginagamit for the tension na tensile is 0.75 for LRFT. So, yun yung mas mahalaga dito. Okay. That is the tensile strength of fasteners. Kung may tensile strength, we also have the shear strength of fasteners, like this one. So, yung kanina yung failure niya is tension failure. Yung shear strength, of course, shear failure naman yun ng bolt, which looks something like this. Right? So, nominal strength of one fastener in shear is equal to this formula. Rn is equal to MAB times 0.62 FUB, wherein yung FUB is still the tensile strength of the bolt material, which is 120 kapag A325 bolt yung gamit, 150 naman kapag A490 na bolt yung gamit. Yung M is the number of shear planes. One yung ginagamit natin na value ng M for single shear, like this one. Ito single shear lang to kasi isa lang yung plane area na nakaka-experience ng shear. Pag double shear naman, ito yung ginagamit natin na value for M. Okay. AB is still the same. Cross-sectional area of one bolt dun sa unthreaded part. Yung FNV, FNV, yan yung tinatawag natin na nominal shear stress of the bolt, which can be found sa ASC table J3.2. That is also called the ultimate shear stress or yung tau units. Okay. So yung mga value ng FNV na yan can be found dun sa the same table na pinakita ko kanina, which is this. So dito naman siya nakakuha yung FNV. Ito yung mga values niya. For A307 volts, ang FNV niya for resisting shear ay 24 KSI or 165 megapascal. And so on and so forth. Okay. So mapapansin nyo, iba yung value ng nominal shear stress or yung FNV dun sa mga bolts na excluded yung threads sa shear plane, tsaka not excluded yung threads sa shear plane. Okay. So ano bang ibig sabihin ng mga threads are not excluded tsaka threads are excluded? Kasi nga, as I mentioned a while ago, yung bolts natin, like this one, may mga threads yan. Threads. Yan, ganyan. May mga threads yan na ganyan. Okay. Pag yung shear plane or yung plane kung saan nag-a-act yung shear ay sumakto dun sa location ng thread. Ibig sabihin lang yan, threads are not excluded from the shear plane. Ibig sabihin hindi siya nakatanggal dun sa shear plane yung mga threads. Or ibig sabihin nandun siya sa mismong yung shear plane mo nandun sa mismong thread, yun yung ibig sabihin. So if that is the case, makikita nyo yung nominal shear capacity mas maliit compared dito sa kapag excluded yung shear plate sa threads. Okay? So obviously mas maliit talaga to kasi nga kung sumakto sa thread yung shear plate mo, sabihin lang nun yung shear area mo mas maliit compare dito sa shear plane na hindi sumakto sa thread. Okay, so yun yung iba nung dalawa. So later on, we will try to clarify that more. Ito yung specific code provision for the shear capacity of bolts. So same provision lang to as before. Ang pinagkaya pa lang is yung value ng Fn. Yung Fn natin kanina is FNT kasi nga we are talking about tension strength or tensile strength. Ngayon, yung Fn natin will now be FNB since we are now talking about shear stress or shear strength. AB same pa rin naman yung definition. Okay. For threads excluded in shear plane, ibig sabihin shear plane hindi sumakto sa threads. To account for the approximately 20% reduction in strength of connections up to 50 inches, yung formula natin coming from here becomes this. So 80% lang yung kinukuha natin dyan kasi nga magkakaroon ng 20% reduction. So 80% na lang yung matitira. And then, pag multiply natin yung 0.8 sa 0.62, 0.8 times 0.62, the result is mga nasa 0.5. Okay? So yung part na to, yung 0.5 FUV, that is the FNV na nakikita natin from the table kanina. Okay? Technically, itong formula na to, tsaka to, nasa code pares lang yan. So, tinanggalan lang natin ng M to, yung sa code, kasi we don't need to include naman kung ilan yung shear plane pagdating sa code. Kasi, ini-include mo na yun sa AB. Okay, ini-include mo na yun sa AB. So, syempre, kung dalawa yung kung double shear siya, times 2 mo na lang to automatic. Okay. So, that's for threads excluded in the shear plane. For threads included in the shear plane, sabihin sumakto yung shear plane dun sa threads. Yung RN natin, or the area at the root of the thread should be used, which is the 0.75 AB. So, from this formula, i-reduce natin siya ng 20%, so 0.8 na lang. Tapos yung AB na gagamitin natin, hindi na siya basta AB na lang. Kailangan natin siyang i-reduce ng 25%. So 0.75 na lang ang gagamitin natin. So simplifying 0.8 times 0.75, 0.62, ito yung lalabas. Yung 0.4 FUB na yan, that is the FNB, same FNB na ginagamit natin for this formula of shear strength ng bolts. Okay. So dito sa formula na to, we can have a generalization wherein makikita natin na yung shears, yung FNB for threads excluded in the shear plane is just 0.5 ng FU, ng FUB. 0.5 na to, ng 120 or 150, depende kung K3 to 5 yung gamit. And then yung FNB for threads included in the shear plane is 0.4 lang ng FUB. 0.4 nito or you can check that out dito sa table kanina. Makikita nyo, kunyari sa A325, kapag threads are excluded in the shear plate, yung FNB niya is just 0.5 na 120, which is equal to 160. Kapag included naman, 0.4 ng 120 or nasa 30. 30. 0.4, 48 pala, sorry. Nasa 48 KSI. Okay. So lastly is the bearing strength at bolt holes. Okay. So yung bolts natin, usually in contact yan sa mga plates. So kapag sobrang laki na ng load na kani-carry or transfer ng plate pagka sa bolts, nagkakaroon na ng bearing failure of the plate. Okay. So we also consider that as the strength of sa pag-compute ng strength ng connection natin. So yung bearing strength at bolt holes can be computed using this formula. 2TLC, tau UP, where yung tau UP is just equal to 0.62 ng FU. And then simplifying that, ito yung lalabas ng final formula. Wherein yung Rn natin is the nominal bearing strength of one bolt hole or the bolt hole nearest the edge when there are two or more bolt holes embedded in force, which is the force applied against the side of a hole to split or clear the plate. So ito yan, yung force na nag-act dito sa bolt hole na yan. Yan yung Rn natin, nominal bearing strength. So yung ginagawa ng nominal bearing strength na yan is trying to prevent tearing or splitting like this one, diba itong failure. It tries to prevent that kind of failure, which is actually a shear failure. Yung LC natin is the end clear distance along the line of force measured from the edge of the hole to the edge of the connected part or the plate or the clear distance between the holes. Larger value reduces possibility of splitting failure. So yung LC natin, kung meron tayong ganitong connection, ito yung bolt hole. Yung LC natin is just this distance from the edge of the hole papunta dun sa edge. sa yeah, and clear distance yung distance yan. Yung LC natin is the distance from the edge of the hole talaga sa edge ng connected part or the plate, okay, which is defined as this. Yung actual tearing would occur along lines 1, 1, and 2, 2. Usually, if alpha, if we have alpha equal to 0 as the lower bound. So kapag sa actual kasi, yung tearing usually happens like this. But if we will try to compute for the lower bound, where yung alpha is the 0 or horizontal lang yung tearing plane, yung actual tearing will happen obviously sa plane 1, 1, tsaka sa 2. Yung tau UP natin dito is 0.62 FU as once in a year. That is the shear strength of a plate material. So, makikita nyo yung FU dyan, wala siyang B. Makikita nyo yung FU dito, walang B sa taas kasi nga it pertains to the plate. Pag may B, FU yun ang bond. Pag wala, sa plate dyan. Okay, yung FU, tensile strength of the plate material. When LC is 2.5D, D is the diameter of the bolt hole. Yung formula natin, which is this, we will try to substitute in place of LC yung 2.5D. The formula will be equal to this. So ito yung formula for the bearing strength when tear out is prevented. When no rupture occurs, the elongation of the hole may be excessive. Thus, the tear out prevented formula should be used only when the deformation around the hole is not of concern. So ito yung specific provision for the bearing strength at bolt holes which can be found sa AASE J3.10. So yung mga formula na pinakita ko kanina, ito especially this, nandito rin yan sa hole. So yung fee natin na ginagamit is 0.75. And then meron tayong iba't ibang cases na check. Unang case is for a bolt in a connection with standard, oversized, and short-slatted holes. It depended on the direction of loading or a long-slatted hole with a slat parallel to the direction of the bearing force. Kung papasok ka doon, yung bearing strength natin will be either of the two. Itong una or itong pangalawa. Yung pangalawa is ginagamit when deformation of the bolt hole at service load is a design consideration. Pangalawa naman, when deformation of the bolt hole at service load is not a design consideration. Okay. Next case is for a bolt in a connection with those slatted holes with the slat perpendicular to the direction of force. Kung familiar kayo dun sa mga slatted bolt hole. Kung ito yung plate mo, ito yung force mo. Kung yung slatted hole daw, which is look something like this, yung parang pahaba na ganyan, bolt hole. Bolt hole yan, hindi siya basta ganito below. Parang papahaba siya. Kung directed daw siya, perpendicular to the direction of the force. So, dapat daw naka-perpendicular siya. So, ganito dapat yung orientation niya. Kung ganyan daw yung orientation ng slatted hole, dito ka pasok sa letter B. Sa letter A, for standard, oversized, tsaka short slatted holes. Okay. Itong ganitong case sa letter B, ito yung formula for R. For connections made using bolts that pass completely through an unsteepened box member or HSS, you can just look for section J7 tsaka yung equation J7 na siya. Okay. For connections, the bearing resistance should be taken as the sum of the bearing resistances of the individual bolts. Bearing strength should be checked for both bearing type and slip critical connections. The use of oversized holes and short and long slatted holes parallel to the line of force is restricted to slip critical connection. So yung slip critical, later on pa natin i-discuss. But that is another part of connections. Next part for connections ay yung geometry of bolted connection. So if you will try to refer sa ASCJ 3.2, you can see there the corresponding size and use of holes. Ito yung mga code provisions for finding the corresponding size of holes. Okay. So yung mga size ng hole natin, pag sabi natin nominal yung size ng hole, ibig sabihin lang nun, yung hole natin, or yung mismong hole, ay equivalent dito sa mga nominal dimensions na nakalagay dito. If you will try to refer dito sa leftmost, nakalagay dito yung bolt diameter. Okay? Yung bolt diameter, hindi siya parehas ng nominal hole diameter. Kasi yung nominal hole diameter, usually, that is 1/16 inches larger than the bolt hole bolt diameter, sorry. Okay. So like this one, 1/2, dagdagan natin siya ng 1/16 plus 1/16. The answer would be 9/16. So yun yung magiging nominal hole diameter ng hole for a bolt diameter of 1/2. But that is for standard size. Wala nga. Pag oversize, 5/8. Pag short slat, pag long slat, ito. Okay. So yun yung mga hole, nominal hole dimensions in US customary units. Yung naka ano naman, yung naka SI, ito naman. And then, if you will try to refer sa ASC J3.3 to J3.5, makikita mo doon yung mga provisions for minimum spacing ng mga bolts. So, hindi mo kasi pwedeng sobrang lapit. I mean, yeah, hindi mo kailangan, hindi pwedeng sobrang lapit ng mga bolts sa isa't isa. So, sabi dito sa code, the distance between centers of standard, oversized, or slatted holes shall not be less than 2 and 2/3 times the nominal diameter D of the fastener. Nominal diameter yun, guys. A distance of 3D is preferred. Okay. So, kung meron kang dalawang bolt dyan, ito yung center nila. Sabi dito sa code, yung spacing na yan must be a minimum. Sabi, hindi na sila pwede magdikit dyan. Ng 2 and 2/3 ng D. And again, take note yung D is the nominal diameter. So, nominal yan, sabihin may plus 1/16 yan ng bolt diameter. Yan yung D na sinasabi niya. Although preferably, instead of 2 and 2/3, preferably 3 times D ang ginagamit dyan, the minimum spacing. But that is preference pa lang naman. Minimum edge distance, hindi rin naman pwede na kung meron kang connection na may bolt dyan, hindi pwedeng sobrang lapit ng distance na to from the edge of the plate. So according sa code, the distance from the center of a standard hole to an edge of a connected part in any direction shall not be less than either the applicable value from table J3.4, which is this, or J3.4M, which is this. So dito, nakalagay na yung corresponding minimum edge distance depende sa bolt diameter, tsaka depende kung at sheared edges siya or sa rolled edges. Okay. And then, kung may minimum edge distance, meron ding maximum spacing tsaka maximum edge distance. May minimum spacing tsaka minimum edge distance, meron ding maximum. Okay? So, according to this, the maximum distance from the center of any bolt or rivet to the nearest edge of parts in contact shall be 12 times the thickness of the connected part. 12 times the thickness of the connected part under consideration. Yan yung maximum distance from bolt to another bolt. But shall not exceed 6 inches or 150 mm. So, yan ang pinaka-maximum, yung 6 inches or 150 mm. Yan yung pinaka-palayong distance ng bolt to bolt. The longitudinal spacing of fasteners between elements in continuous contact consisting of a plate and a shape of two plates shall be as follows. For painted members or unpainted members not subject to corrosion, the spacing shall not exceed 24 times the thickness of the thinner plate or 12 inches. For unpainted members of weathering steel subject to atmospheric corrosion, the spacing shall not exceed 14 times the thickness of the thinner plate or 7 inches. Okay. So ito yung mga corresponding edge distance increment naman depending on the nominal diameter of the fastener. So yan yung naka-inches at yung naka-mm.